Welcome everyone. I'm starting this course for people who are absolute beginners in PTC CREO software, people who have no knowledge about CAD modeling using PTC CREO. I will be using PTC 6.0 edition in this series, but even if you have a lower or a higher version, it should not be a concern. So in this first session, I'll be talking about a very important concept, that is the concept of strong and weak dimensions. So right in front of you, you can have a look. This is what you will see whenever you open PTC CREO. This is the interface. So the first thing that you need to do whenever you open up PTC CREO is to select the working directory. The directory where basically you will save your entire work. So right at the top, you can see there's an icon that states select working directory. When you click on it, you can specify the location as per your convenience. I've already selected my working directory. The next step is to click on new and select a new sketcher plane. So when you click on new, a dialog box opens and you can see a list of options. You have the layout, sketch, part, assembly, manufacturing, drawing, format, notebook. You have the subtype, solid modeling, sheet metal modeling, and bulk modeling. We'll be taking them one by one over the next few weeks. Let's first start with the sketcher plane. So you need to specify a file name. Let's assume I enter something like trial_2 and click OK. So this is the name of the file I will be working on in this session. So as and when you do that, you have a list of options that pop up right at the top. This is what you call as the sketcher pane or the palette, which helps you to construct the geometries. Now, let's begin with the very basic line command. How can you construct a line using PTC CREO? And how can you use that to construct geometries? So once you go on line and click on it, you have two options. One is a line chain and a line tangent. We'll just talk about the line chain command, and we'll take the line tangent command in the next session. So click on line chain. Now, you can click anywhere as per your convenience, and after that, leave the mouse and just drag it a little away from the point. So you can see that as and when you do that, a line is constructed, and at the bottom, you can have a look. You can see a green symbol with a dash. This is what you call as the horizontal constraint. You may or may not want to constrain this line horizontally. If I move the mouse upwards, you can see that the constraint disappears. And if I move it back here, it appears again. And if I move down, it again disappears. Let's say I want to have the horizontal constraint for this particular session. I can click the mouse button again, the left mouse button, and the line is created. Now, but the line is not finished yet because it's a line chain. So if I hover the mouse away from this point, you can see I still have the line chain with me. If you want to end it, you need to click the middle mouse button. So when you do it, you can see the line is constructed and it has a dimension. We'll talk about the dimension after a few minutes. So you can again go to the line command, select line chain, and come back at this point. Now, once you click again on this point, you again join the point on this line. And if you hover the mouse away from this point, you can see you can construct another line. This time you can see another green symbol, but the dash is pointing in the upward direction. So this is what you call as a vertical constraint. You may or may not want to have the vertical constraint, as I pointed earlier about the horizontal constraint. So let's say for this particular session, I would like to retain the vertical constraint. And I want to end the line at this point. So I click the left mouse button. Now, again, you can have the line chain back with you. If you click the middle mouse button, the line chain will end at this particular point only. But let's say I want to construct a geometry. I want to construct a pentagon. So I can hover the mouse away from this point, something at this location, click the left mouse button, come down, and then again, I can click here. So you can see that PTC CREO is suggesting me that if you click at this point will be aligned with this particular point down here. If you move it away, the alignment disappears. But if I hover back, you can see you can see it gives you the option to align it back. So you can click at this point and then join this point. I haven't joined it, as you can see. Now when I will click this point and I'll end the line chain, please notice the color within the pentagon. So I click on it, I join the line, and I will click the middle mouse button to end the line chain. So you can see the geometry inside the pentagon turns into pink color. It gets filled in. The reason is, whenever you will make a geometry that is enclosed by all the points, it will have pink color in it. So this is what you call as a complete geometry. But what would happen if I had not joined the last line with this point? Let's talk about that. Let's say I want to delete this line, just to explain you the concept, like what happens if I don't join those last 2 points. So you click on this line and you can click delete. So the line gets deleted. So you can again go back to this line, click on this point, and instead of joining it, I leave it a little farther away, let's say at this point. Now once you do that and you go away and click the middle mouse button to end the line chain, you can see this time the pentagon did not get filled in with pink color. So this is something I've already specified, or the PTC CREO software allows you to specify as well. So if you go to this right hand side button, you can see here, there is this option which you call as highlight open ends. So I've already selected it. So it highlights the vertices of sketched entities that belong to only one entity. It means that these 2 points need to be joined in, otherwise you have open ends. So this option helps you to identify the open ends. And the second option is to shade closed loops, because now since this is not closed, that's why it's not shaded. But if I take the line command again, select line chain, and if I specify or join these 2 points, you can see the pentagon now will be filled up with pink color again, because now it is shaded. It's a closed loop. But I would avoid joining these 2 points in this particular case, because what I've done is I've created an extra dimension. I don't need this dimension. I just need 1 dimension here. So in order to deal with this, it's better to always specify the complete line. So I'll just undo this. I'll delete this line and I'll delete this particular line as well. And instead, I'll just join them with a single line. All right. So as you can see, I've gotten rid of the extra dimension I was getting earlier. So now let's talk about the concept of strong and weak dimensions. See, whenever you create any entity, like the one we have created in front of us, weak dimensions are automatically generated. Now, weak dimensions appear blue in color and they are temporary dimensions. You can see all these dimensions here, they are blue in color and they are weak dimensions. We didn't specify them. PTC CREO automatically created them. Now, these weak dimensions are arbitrary dimensions that CREO adds to keep the sketch fully constrained. They rarely correspond to the design intent. They're not a part of the design. PTC CREO just created them on its own to make the sketch constrained. So now, as a golden rule that would help you is that you should never leave weak dimensions because they are arbitrary. So do remember, we need to get rid of weak dimensions in our modeling. So how can we get rid of these weak dimensions? So when you go and modify a weak dimension to satisfy the design intent, it becomes a strong dimension. And strong dimensions appear black in color. For example, if I go to this dimension and I click on it, you can specify here it's as a strong dimension. Let's say my design intent was to specify the length of this line as 9 mm. So as and when you do that and you click outside, you can see that a black dimension appears, and this is what you would call as a strong dimension. You can change other dimensions in a similar fashion. Let's say I want to change this dimension. I go to this dimension and I click. My design intent was to make this particular line of 6 mm length. And my design intention was to make this particular line again of 6 mm length. So you can see, using this technique, I have achieved 3 strong dimensions and 2 weak dimensions. Now you can also identify strong and weak dimensions by moving the cursor over the dimension. For example, if I hover my mouse over this particular dimension, it states strong. And if I hover my mouse over this particular dimension, it states as weak dimension. Now, another point that should be noticed is that the weak dimensions automatically get deleted if another dimension conflicts with them without even prompting the user. On the contrary, strong dimensions will never be deleted if another dimension conflicts. The conflict manager opens up instead. Let's understand this point. See, let's try to specify one dimension now. This is the option to specify a dimension. So if I take this dimension and I specify the distance between these 2 points, let's say the distance between this point and this point, we know it should be 9 mm. But let's try to specify this dimension. I click on these 2 points and I hover my mouse up and I click the middle mouse button. See what happens. The conflict manager opened up and it states that the highlighted 2 constraints and 2 dimensions conflict, select one to delete or convert. So if you see, this is SD10 dimension, that is 9 mm that I wanted to specify. This is SD0 dimension, that is the one I have already specified. This is the constraint on the horizontal or the vertical, that is these 2 points, they should be aligned on the horizontal axis. And the constraint is here that it is the vertical axis. Let's take them one by one. Let's say I want to specify this particular dimension, which I've already done here, and I want to remove or get rid of this dimension. So I need to click this dimension and click on delete. So as and when I do that, now I can specify this dimension and I can change it from 9 to let's say 12. So you can see I'm in a position to do that. What are the other 2 options? I'll click undo. I'll click on dimension. I'll again try to specify the distance between these 2 points. There will be the conflict manager. Now let's delete these 2 constraints one by one. So let's first delete the constraint 3 and I click on delete. So I've already deleted the constraint, as you can see. Let's change the dimension to 12 instead of 9. See what happens. So you can see that if I want to have this particular dimension, I need to get rid of the horizontal constraint. What is the last and final option now? Let's click on dimension. And let's delete the vertical constraint now. And let's change the dimension to 12. Again, you can see that the geometry is getting disfigured because we are getting rid of the constraints. This time I got rid of the vertical constraint. So this is not what we want. We need to specify some other dimensions. So let's say my design intent was to specify the angle between this line and this line to be 120. So I click on dimension and I'll click on this line, and then I'll click the middle mouse button. As and when I do that, you can see that this particular weak dimension got automatically deleted. So this is what I meant when I was trying to say that the weak dimensions automatically get deleted if another dimension conflicts with them without even prompting the user. So let's say I would specify this dimension as 120 mm. Let's again assume my design intent was to specify the angle between this line and this line as 120 degree. So again, you can see as and when I do that, the weak dimension between these 2 lines got eliminated on its own. So let's say I would specify it as 120. So as my golden rule that I talked about earlier, I have eliminated all the weak dimensions, and that is something I will be continuing to do in the upcoming sessions as well. So this is what I would call as a fully constrained geometry. So I hope you got the concept of weak and strong dimensions, and you clearly understand that you're still in a position to change any strong dimension as per your choice. I can change anything here as well. But the geometry is fully constrained. All right. So let's keep on modeling and let's meet you in the next session. That's it for now. Thank you.